So we're going to be continuing on, and we're going to be talking about cosine and sine, hopefully. But before we do that, we're going to finish up rads and areas, then talk about cosine and sine functions, and more on circles and trig functions. So what all this words say on the screen is essentially what we can do for angles, we can do for radiant measure as well. So essentially, I'll just draw the picture over here. Suppose you have like a radiant and it's positive. So this means you're going around the circle in the counterclockwise direction like this, which makes sense. And that is with respect to the positive horizontal axis. The radius corresponding to a negative angle, let's draw the picture, is obviously the same thing, but it's going clockwise around the circle. And it's with, of course, again, with respect to the positive horizontal axis. You could read all that to understand. So the radius corresponding to an angle theta, this is the Greek letter theta, is this magnitude greater than 2 pi? Now let's understand, sketch the radius of this unit circle corresponding to like these values. I put in some, I'm not the best circle drawer, as you could see. So I already had this filled in. Oops, and I can't draw lines either. Okay, so we can imagine this is the unit circle at like 1, 1, -1, -1. And we're going to sketch the radius of this unit circle corresponding to this point. So 3 pi. So what is 3 pi? So 3 pi is just 2 pi plus pi. It's the same thing, right? 2 pi plus pi is 3 pi. 2 pi is essentially one loop. So this means we start at this positive x horizontal axis, and we go around once. So we're back kind of where we began, and then we go pi. So then we continue on, and then we're over here. So this is what it means. What about 9 pi divided by 2? So 9 pi divided by 2 is the same as 2 pi plus 2 pi plus pi divided by 2. And you could check this, that they add up to 9 pi over 2. Because this would be 8 pi divided by 2 plus pi, so that's 9 pi divided by 2. And you see that we would have 2 loops. So let me try to draw the axis. 1, 1, -1, -1. So you begin here, or anywhere on this axis, this positive axis. You go around once, go around again twice, and then you go pi divided by 2. So then you go over here. So the answer is this part. And the answer here was over here, where it ended up. Do you see? Okay. What about the last one? -5 divided by 4 pi. Just try to draw the axis. So we have 1, 1, -1, -1. So we have a negative value. So this is like negative pi, subtract maybe 1/4. You could kind of like write this out yourself. So we're going in, because there's a negative, we're going in the clockwise direction instead of the counterclockwise direction. We start at the positive axis. So we go negative pi, and then we go 1/4. So about here. So it would be around this axis. So those examples basically hint at this following definition. So if you have like theta and you add multiples to this, like 2 pi times n, where n is basically any integer in radians, you get back that particular angle. Which kind of makes sense that we're just adding that 2 pi. It's same as degrees. Sort of like we're adding multiples of 360 degrees and n, you get back where you began. Or this is where we're adding multiples of 2 pi times n radians, and we get back where our angle. Now this is kind of interesting, the length of a circular arc. Now suppose 0 is less than our theta is less than 2 pi. Then a circular arc on the unit circle corresponds to theta radians, and it has the same length. So let's draw the picture. So our unit circle, and this is how they define it. So this means, let's say you have an example of where our angle here is pi divided by 4. So this means the angle on the unit circle with this measure pi divided by 4 radians. This therefore also has the length, the arc length here on the unit circle is, what is it by this definition? What is this? The length of this arc, you could call it arc length. Pi over 4? Did I hear that from the audience? Yes? Yes, it's pi over 4. So it's kind of interesting. It's kind of really cool. So if you know this angle, you know the length on the arc of the circle. It's the same thing. Interesting, right? It's actually quite interesting. Now we know the circle, and I think the area of a circle with radius r, I think you know this from high school. The area is equal to pi times r squared. Now, here's an example using this formula. So suppose you have a 12-inch pizza. So we know the diameter of the pizza is 12 inches. Because like that's how you measure pizzas, through the diameter. So this implies, therefore, the radius is 6 inches. Okay. So we have this 12-inch pizza and it's cut into 8 slices of equal size. What is the area of one slice? Well, we can do the area of the pizza. It's just therefore going to be pi times r squared. By definition, pi, r is 6, so 6 squared. So this is going to be 36 pi. Now the area of one slice, therefore, is just going to be, what is it? Anyone? Yeah, 36 pi divided by 8, because there's 8 slices in the pizza. So you divide, because we just want per one slice. So, and then we can reduce this, 9 pi divided by 2. So this question, maybe there's no point to this actual question, but it helps us practice the formula. And it actually, one idea could be like, suppose we're making boxes to fit the pizzas in. So maybe then we care about the area. That would be an application. This generalizes the area formula into this. So suppose the area of a slice with this particular angle inside a circle with this radius has this formula. It's not a big deal. I won't test you on this. But I could just like leave it to you to understand that if you wish. It's in the textbook. Now, just like we have been given angles and degrees, we can find the coordinates of the endpoints of the radius of a unit circle corresponding to some special angles. So find the coordinates of the endpoints of the radius of the unit circle corresponding to 14 pi divided by 3 radians. So let me draw my axis through my circle. So what is 14 pi divided by 3? Well, like we're going to have like 3 divided into 14, be 12. Like we're going to have a 12 and then a remainder. So that part will be 2 pi plus 2 pi plus 2 pi divided by 3. And you can work and see this math if you can't see it immediately. So this would be 2 loops. It goes around the unit circle. In the positive direction. So this means you go around once, twice. Okay. Actually, I'll draw it for you here. Once, then twice. Okay, and then we continue going 2 pi divided by 3. Now, you know, half of the whole thing is 2 pi. So half of it would be pi to this particular point, right? From here to here, it's just pi, because the whole thing is 2 pi. So 2 pi, so pi divided times 2 over 3. You know, this angle is sort of like 180. 180 divided by 3 would be, or be 3 parts. 1, 2, 3. So just intuitively seeing that. So it's going to be over here. So 2 pi divided by 3 is actually 120 degrees. So it's this point here. That would be the end point of the radius. Okay, so we could project this onto this axis. So this is our 90 degrees. This part, so you could see it that, and I'm not drawing it, well, maybe I could, in a different color. So this part would be like, let's say, 60. This would be 60. So this would be 30 and 30. And this would be 60. Let's use a color. So this part here is 30. This would therefore, if this angle is 60 by the Z from high school, your angles from, and also just because this is 30, this is 90, this therefore is also 60. This is that, let me write it down. This is the 30, 60, 90 triangle. So we know this that from before, and we know the radius is 1. So this is therefore the 30 across is going to be a half, and across from 60 is the square root of 3 divided by 2. So this point, therefore, because we're going in the negative x-axis, you read this point down. So this is negative a half, because it's going this way. And this is going to be positive square root of 3 divided by 2. So that is our point. Now let's talk about cosines and sines. And they're best understood through this unit circle. So different textbooks use different approaches. We're just going to follow what our textbook does. So the endpoints of the radius of the unit circle correspond to theta degrees, have these coordinates. So the first coordinate we say is cosine of the angle, and the second coordinate is sine of the angle. So we can kind of draw it. I'm going to take a little time here. Again, this is all one, our unit circle. And this is our angle. Actually, I'll just use a dotted line. So if we have our angle, this point here is, to repeat it, is cos of the angle. And it's this ordered pair, cos, sine of the angles, respectively. And again, remember, we're going in the counterclockwise direction. So let me write it out, that triangle, a little larger for you to see. So we have, this means the cos, because it's in the x direction, it's down here. This is our angle. This angle over here is just, well, I won't get into it. This is sine of the angle, and remember the radius is 1. Okay. This is the other corresponding angle. So this first cosine is basically our x point, and the sine is our y point. I hope you can see that. I could write like this is basically our x, and this is basically our y. Now let's evaluate these cosine and sine at pi divided by 2. Okay. So pi divided by 2, we know that is just when we go from this angle to this axis. So it's just this pi divided by 2. Because pi divided by 2 is 90 degrees. Let me write in a different color. This point up here, what is that? So the cos of this angle and the sine of this angle. Well, what is cos? Here, cos of pi divided by 2 and sine of pi divided by 2. Well, we rotated, sort of like thinking it's almost like an arm rotating it up. This is equal to, well, the first coordinate is our x. So our x is, what is our x here on this axis? 0, perfect. 0. And what is our sine, our y coordinate? 1, right? 1, perfect. So the cos of pi divided by 2 is equal to 0, because that's our x value. And sine of pi divided by 2 is equal to 1. So we kind of got lucky, honestly, with like these numbers, 0 and 1, right? It's kind of easy. It's not so bad, hopefully. So it's actually useful to know the cosine and sine values of some special angles that arise kind of frequently. We know, so the 45, so this pi divided by 4 is the 45, 45, and 91. These other ones are the 30, 60, and 90. This is 30, 60, and 90 triangles flipped. So these are special triangles. So, and the other ones down here, like 90, 0 and 1, negative 1 and 0, 1 and 0, you can kind of like derive these. So how to read like this chart? So let's say, for example, our theta here is 60 degrees. So therefore, the cosine, so the cos of 60 is 1/2. And then therefore the sine of this angle, is going to be square root of 3 divided by 2. This is how we read it from the chart. So maybe I'll give you the chart for your tests or something. So let's evaluate the cos of negative pi divided by 2 of the cos and the sine. So let's draw these. So let's actually use the unit circle. So this angle is negative pi divided by 2. So negative 90 degrees. So we know we're just going to go from, go down, basically, 90 degrees. So we're just going to go to the side. So we started off here. And we kind of rotate. Sorry, downwards. Okay, so then our point becomes down here. So again, this point down here, the cos of negative pi divided by 2, and the sine of negative pi divided by 2. Well, the first value is 0, and the sign here, because it went down, would be -1. This implies, of course, the cos of this value, which is negative 90 degrees, is 0. The sine of negative 90 degrees, I'm just switching back and forth, is -1. So we remembered like this equation of a circle is x squared plus y squared equals r squared. So x squared plus y squared equals r squared. But when r is equal to 1, this is just equal to 1. And this is our unit circle that we know. So we know that this unit is circle equation. So we also just learned that any point on that unit circle has like these coordinates. Essentially the cosine of this angle, this is our x, and the sine of this angle, this is our y for some theta. So therefore, this implies if we sub in x and y into the unit circle equation, that the cosine of this angle squared, sorry, let me just erase the first bracket. Or simplify this. So the cos of this angle squared plus the sine of this angle squared is equal to 1. So this is very useful, super useful identity that comes across, that is used frequently. So the cos of all of it squared plus sine all of it squared is equal to 1. So let's use this to solve this question, to find the cos given these assumptions. So where pi divided by 2 is less than theta is less than pi. So this means where pi divided by 2, this is 90 degrees. And pi, of course, is 180 degrees. So we are going to use that super useful formula, which is just cos of theta squared plus sine of theta squared is equal to 1. Now we can rearrange. So we know sine of theta equals 0.8. So we could plug that in, 0.8 squared. And then we could do some math. So we could subtract 0.8 squared on both sides. We got cos of this angle squared is equal to, so 64, 1 minus the 0.8 squared. So it's 0.36. Then we take the square root. So we get plus or minus 0.36. So this implies the cos of this angle is plus or minus 0.6. So which is it? Is it positive or negative? Well, okay, so back to this unit circle. So you see that it's between 90, so this is our 90, and 180. So it's going to be somewhere in here, let's say. And we know the unit circle has cos of theta and sine of theta. So this cosine is obviously negative because this is our x and x is in that negative direction. So let's just write that down. So since pi divided by 2 is less than theta is less than or equal to our pi, the radius corresponding to theta degrees must be in that second quadrant, because this is like first, second, third, fourth, 2. I think you know that from high school, the quadrants and things like that, right? Yes. So therefore, we know what it is. So from the unit circle, so we see that the cosine is obviously going to be negative. So thus, cos of this angle is equal to negative 0.6. I'll just draw the angle on this. Now we can graph the cosine and sine functions and essentially see what they are. So relating these cosine and sine functions to the unit circle, we can see the range, the domain and the range actually of these functions. And we find that the range so they range from -1 to 1. So the domain goes from -infinity to infinity, and the range goes from -1 to 1. So both of these functions are defined for all real numbers. So that domain is the real numbers. So we go back to like this table, and we can like plot all those values and try to graph this. So it's a bit of an exercise to graph this all. So goes from 1 to -1. Let's start with let's say pi, -pi, divided by 2, -pi. And you can like basically put some values from the table on here. So you do have to like flip back and forth. Sorry. And you can do this at the same time as I'm trying to do it. So remember this x-axis is in radians. Not degrees. And then we just plot those points. So for one of the functions, for like, let's say sine or cosine. So we plot all the values. Let's go back. All the cosine ones, see what we get, connect the points. All the sine ones, plot all the points, see what we get. So I'm just going to kind of try to do this for you. So pi over 6 is a half. Going to kind of cheat. Oh. I should have not spaced them out so far. Okay. I have to redo this because it's not that pretty. Sorry. So just bear with me while I try to draw this out for you. Press. So we can plot like the -1, the key points first. So here, so the sine, so it's 0 at specific points, at pi, at 2 pi, etc. So at pi, at 2 pi, here, down here. I'm just going to kind of connect the points and draw it. So this is the sine function. And then the cosine is kind of similar to this, but it's just shifted. So it actually begins here, goes through this point, goes through this point. And the exact points, you can really go through Google. It doesn't really matter exactly here. You could read the table. So this one would be cosine. For more precise graph, do look at Google. So I know this isn't perfect. Or Desmos. And you'll see that if you plug in, if anyone has a computer and you do it right now, go to Desmos, plug in sine, plug in cosine, and you'll see like this, these two curves that like kind of oscillate and go back and forth. So, but the important point is to observe what are these points. So observe that both functions have a period. And what is the period? So you start, like, let's say you choose any graph, either sine or cosine. What is the period? What does that mean? So you could start down here at -1 on the cosine function. You go up, you go to the top, you go all the way down, and then you begin at -1 again, right? So that is what basically the period means. So it went from -pi to pi. So that difference there is 2 pi. So the period here is 2 pi. And you can also observe that this will continue from -infinity to infinity, but it always is bounded by -1 and 1. Okay. That's the main takeaway. And for like more precise numbers, just look at the table, etc. So there's more trig functions. The tangent of an angle, denoted tan of the angle, is basically defined by this. It is the sine over the cosine. Of course, the cos cannot equal to 0. Denominators cannot equal. So let's look at this, investigate this a little bit further and understand what tan means. So again, I'm going to draw this unit circle I've done it a few times here. Radius is 1. So we have like this point on this unit circle as cos of this angle and sine of the angle, where this is our angle. So if we project it, cos is this value here. And this is our sine value up here. So I'm just going to draw this again. This triangle, 90 degrees. So this means this y point is y theta is this distance here. So that is the change in y. This value here from the origin to this projected point down is cosine. So that is the change in x. The tan, it's just basically the change in y over the change in x, which we've seen before, because that's the slope. And by definition, it's the change in y, the sine. Sorry, I'm just moving this over so you. So it is the sine of theta divided by cos of theta. So again, this is just the slope. So it's the slope of the radius of the unit circle. Corresponding that value to theta. So I know you've seen this before. I just wanted you to see where it was coming from, so like you can remember it like later on. So let's evaluate the tan. So this is equal to, by definition, the sine of this value divided by the cosine of this value. We can like look these values up in the table. And this is square root of 2 divided by 2. This is the square root of 2 divided by 2. So this is equal to 1. Okay, so find the equation of the line in the xy plane that contains this point 3, 1 and makes an angle 28 degrees with a positive x-axis. And here we're given this information. So we're given that the tan of 28 equals, or is approximately equal to 0.53. So we could kind of like sketch this. Just to kind of understand what's going on. So we have this point 1, 2, 3, so 3, 1. So we have a point here. Let's just label it 3, 1. And we have, it makes an angle of like, let's say 28 degrees. So it's about, let's just draw a line through it. It might not be through 1. So this isn't accurate, this part. So this angle is therefore 28 degrees. So we don't really know where it crosses the x-axis. Let me draw it again. So we have this line, this L. And we have 28 degrees that it makes with the positive x-axis. So we know that the tan of 28 degrees is equal to the slope of the line by definition. And this is approximately equal to, given in the hint, of 0.53. So now we know the slope. So the slope is approximately equal to 0.53. And we know a point on the line. And it has like this coordinates 3 and 1. So the 3 is our x and our y is our 1. So we can just use the equation of the line, y equals m x minus x1 plus this point, y1. We know the slope. So this is approximately equal to 0.53 times x minus 3 plus that 1. And we can just compute this and we get our answer. You have to probably use a calculator. We'll just circle it.